Hello guys, in this video I'm going to be going over the beginnings of the cross product. So to start with the cross product, I'm going to first bring up what I showed in my last lesson. You could watch the last video on the dot product to see that, where we basically said that if we have some vector A and we cross it and we dot it with B, we are going to get the magnitude of A times the magnitude of B times cosine theta, where this could be our vector A, this could be our vector B, and this is our cosine of theta, which is the angle between the two. So now what I'm going to say is we want to find some vector that's perpendicular to both vector A and B. So I'll say we want some vector C perpendicular to vector A and also be perpendicular to B. So now that would basically happen when the cosine of theta would have to be pi over 2, which where the theta would be pi over 2 and then the cosine of theta would be 0. So then this whole product over here would be 0. So that means that it happens when A dot B equals 0. And so when we move on from there, we're going to just write it out. So for those two to be 0, we want the that right there is if you have A and B that are perpendicular. So we want to find some vector C that is perpendicular to both vector A and vector B. And so that means that when we do vector A and we cross it with vector C, it'll have a cosine theta being equal to 0 because that theta will be pi over 2, which means that they're perpendicular. So then that dot product over there will be 0. And then at the same time, since it's perpendicular to B also, the dot product of those two will also be 0. And right now we can go ahead and we can just expand this out to what it really means. We're going to be doing this example in a 3D plane. So we're going to have the components A1, C1 plus A2, C2 plus A3, C3 being equal to 0. And at the same time, that B value is also going to, that B dot product is also going to hold true. So we're going to have B1, C1 plus B2, C2 plus B3, C3 also being equal to 0. And now I'm going to go ahead and do some fancy manipulation with this. I'm going to multiply this by B3 and this by A3. And basically what I'm trying to do here is I'm trying to solve for C1, C2, and C3. And right now I'm going to cancel out the C3 by doing that and solve for C1 and C2. So I'm going to get left with on the top, I'm going to have A1, C1, B3 plus A2, C2, B3 plus A3, C3, B3. And then on the second one, I'm going to have A3, B1, C1, B2, A3, C2, and then also B3, A3, A3, C3. And these are both still going to be equal to 0. And now what I'm going to do is I'm going to get rid of the C3 over there by subtracting these two. And I could also factor out the C1 over here. So I'm going to have C1 over here, and then it's going to be A1, B3 minus A3, B1. And then we're also going to have that C2. We're going to have A2, B3 minus B2, A3. And then that C3 over there, they're all the same terms. They're going to cancel out. And so now we can see over here, equals 0, that we have something in the form of C1 times some number plus C2 times some other number equals 0. And we need to find a solution to that. Well, the most obvious solution would be where we say C1 equals P and C2 equals negative Q. That way you're going to end up with PQ minus PQ, which obviously equals 0. And so we need to we're just going to plug in those values now for C1 being equal to this P that is right over there. So we're going to say C1 equals A2B3 minus B2A3. And then we have C2 being equal to negative Q. So C2 equals, I'm just going to flip the order to show the negative. Okay, and now we have solved for both C1 and C2. And we could plug this in to either this first or second equation to get our solution for C3. I went ahead and did that. It's just a little tedious. C3 comes out to be A1, B2 minus A2, B1. And so we could rewrite this as a vector. So if I say, given non-zero vectors A and B, C is perpendicular to vector A and perpendicular to B when, and then we're going to say C1, C2, C3 is going to be equal to A2, here I'm going to give myself a bit more space, A2, B3 minus B2, A3, comma, A3, B1 minus A1, B3, comma, A1, B2 minus A2, B1. And this seems like a really tedious, annoying formula to memorize. So we actually, as we're going to see it in the next video, denote it by using a matrix, which is basically the same thing as writing this, but it just makes everything in our life a little easier. So I hope that you guys understand the basics of what the cross product means, and thank you much for watching, and goodbye.